All right, back to the calculator. Okay, back to the calculator. Consider this function. F of x equals 2 over x minus 1. Set up and solve an equation to determine when f of x equals 4. What would this equation look like? 2 over x minus 1 equals 4. Remembering back to Friday, how do I get rid of that denominator? Multiply both sides by the least common denominator, in this case, which would be x minus 1, right? So on the left-hand side of the equal sign, what happens? Those cancel, right? So we end up with what? 2. Now on the right-hand side of the equation, what happens? We distribute. We end up with 4x minus 1. Okay? Excuse me. Thank you. 4. So now what? Add the opposite to both sides? What the heck does that mean? Add 4 to both sides. 6 equals 4x. Divide by 4. X equals 1.5. Close. 1.5. So check your answer to make sure it's correct. How do you do that? Plug it in. 1.5 minus 1. 0.52 divided by 0.5. 4. Oh, look, 4 equals 4. Yay for us. Now, look at this inequality. How is this different from the equation we just talked about? Just the sign, right? Everything else is the same. So, the steps to solving an inequality are the same. So if we have 2 over x minus 1, guess what the first thing we're going to do is? Multiply it by the least common denominator, which in this case is x minus 1. Okay? So we end up with 2 is greater than 4x minus 4. So 6 is greater than 4x. So if I divide both sides by 4, I get 1.5 is greater than x, greater than or equal to, or x is less than or equal to 1.5. Did I change anything here? What did I do? I wrote it in the right order, right? Okay. However, in the case of this rational function, the solution is it's not correct. So let's see why. Let's look at the table. Okay? Do you remember on your calculator how to make your table count by something other than ones? Okay? So we're in graph, right? I want to put in my rational function. Do you remember the whole control divide thing? Control divide? It gives you visibly a fraction. It is legit. That's why I showed you. So 2 over x minus 1. So that's what it looks like, right? So if I go to the table, Control T. Oh, here's another cool thing. And I learned this actually last week. I just didn't know. That's how I knew we needed to get the new operating system. Press Control T to get the table to open. You remember what we had to do to get the table to close before? We had to scroll over and press the graph so it was highlighted and press Control T. Don't do that. Just press Control T. It wouldn't work before. On the old operating system, it didn't work. Okay? So, we already know yours is broken. So how do we get this to change? How do we get this to count by something else? Menu, table, edit table settings. We want to start at 0, but we want us to count by 0.5s. Okay? Did I put something in my graph wrong? No, but see, my problem is this. At 0. Oh, 0.5. Thank you very much. There we go. Okay, so 0.5, this is -4. At -1? What? Why is it undefined? Oh, an asymptote. I see. Okay. Wait, is it an asymptote or a hole? It's an asymptote. How do you know? Because there's nothing to cancel in the numerator, right? Okay, you remember that? So 1.5 is 4. 2 is 2. 2.5 is 1 1/3, basically, right? 3 is 1. No. Okay. So on the table, circle the entries where x is less than or equal to 1.5. It's like here, right? That's on the table. Well, not counting the top x, but those. Those are the entries where x is less than or equal to 1.5, right? Now shade the entries where x is greater than or equal to 4. Whoops, I missed one. Okay, time out. If I'm supposed to be circling where it's less than or equal to 1.5, you got to circle 1.5. You did that? Good. I just messed up, okay? Now shade where the value of the function, the y values, is greater than or equal to 4. That's only there, right? Do those sections match up? If they matched up, what would be true? They would be exactly the same values, right? Do they match up? No. Only one entry does. What I'm trying to do here is show you why this is not correct, because according to the math it is, right? But I need to show you according to the actual function it's not. So this is one of the ways I'm going to show you that. We're getting there. Okay? So turn the page over. In the previous example, the one we just did, the algebraic solution here to the inequality did not seem to agree with the tabular solutions. We're still trying to figure out why, right? Table, tabular, table. Are we good? A better table may provide more information. How is this table different? Okay, so let's go menu, table settings. Where do I want to start? 0.8, and I want to count by 0.1s. Okay, so that is -10, like it says in my calculator. That is -20. That is an error or undefined. What is 1.1? 20, and 1.2, 10. So 6 2/3. 1.4 is 5, and 1.5 is 4 3 1/3. Does this give us a better view? Does this provide us with more information? Circle where the entries are less than or equal to 1.5. Almost the whole thing, right? All of that. On a table, shade where the entries are, where the value of the function is greater than or equal to 4. So all this, right? All of these. Where do these sections match up? From x is, like, it kind of starts right here at the asymptote, right? We know it's not at the asymptote, but we can tell it's in between there, right? From x equals 1 to where? equals x equals 1.5. And we've already talked about this, but let's go ahead and get it written down. What's happening at x equals 1? Vertical asymptote. So the actual solution to this inequality is where x is less than or equal to 1.5 and what? Greater than 1. Absolutely. So let's use this graph to determine the intervals where the inequality is true. Do you know what I mean by intervals? This is an interval from here to here. Okay? The equation at f of x equals 1 has a solution of 3. Does that make sense? When the value of the function, when y is 1, x is 3. Does that make sense? Over what intervals is the value of the function greater than or equal to 1? It's this part right here, right? When is it greater than or equal to 1? When is the value of the function greater than or equal to 1? From the asymptote, because it's greater than 1, to what? Less than or equal to 3. Sorry, I didn't mean to write 2. I guess I really meant and. Over what intervals, so this is the pink question right here for me, okay? Over what intervals is the value of the function less than or equal to 1? Where's the value of the function less than or equal to 1? Isn't it here and all this? So how do I write that? X is less than 1, because it's everything to the left of 1, but also x is greater than or equal to 3. Does that make sense? Yes? Okay. So that was talking about point A. See, they even told us that. That was talking about something about point A. Now let's talk about something about point B. The equation, the value of the equation is -2. It has a solution of 0. So when the value of the equation is -2, the x value is 0, right? Okay. So on what intervals is the value of the function, the y values, less than -2? When is it less than -2? When x is greater than 0 and when x is less than 1. Greater than or equal to 0? Right? It's just this part right here, the yellow part. Yes. Okay. Now it does say show symbolically and on a number line. We got number lines, yes? Here's 0, here's 1. It's greater than 0 and less than 1. Well, it would be if I would read the question. I just read my sign wrong. Okay? You probably did it because I said it. Okay? If this sign actually said less than, let's just change it since we're on a roll. Because we were talking about when is it less than that, right? It's less than that point when x is greater than or equal to 0 and less than 1. On the number line, that would be greater than or equal to 0 this way and less than 1. So it's all that stuff, right? Right? Okay. But it's, oh, this is a different question than last time. How is it different than last time? How is it different than point A? What is it asking? When is it less than -2? Can 0 count? If we're talking about less than -2? So it's just greater than 0. So this should be open, right? So we made like 18 mistakes on that problem, right? Can we fix it on this last one? Can we redeem ourselves? Remember, we got to change this last one to be greater than, because we just changed our whole problem. So when the value of the function is -2. So when is it greater than? So it's less than 0. X is less than 0. And what? Where else? I'm covering with the thing I need to color with. So it's that area and all of that area, right? So that's taking the x values are less than 0. What are these orange values up here? X is greater than 1. Why not greater than or equal to? Oh, 1's an asymptote. I can't get there, can I? Okay, so what's my number line look like? Here's 0, here's 1. Less than 0. What kind of circle on 0? Open, and to the left of 0, like you said, and then open on 1 and to the right. Does that make sense? All right. Somebody come and grab these real quick, please. Thank you, Lucas. So look here. Look here. They gave you the equation, but they also gave you the graph. Okay? So set up and solve an equation to locate the vertical asymptotes of this function. How do we set up and solve an equation to locate the vertical asymptotes? Good. Set the denominator equal to 0, right? Denominator in this problem is 2x minus 3. If I set that equal to 0, I add 3 to both sides. So I get 2x equals 3. When I divide both sides by 2, what does x equal? 1.5. So there is a vertical asymptote at 1.5. Which we're going to draw in. Okay? Any questions about that? Point A has an x-coordinate of -3. I'm going to finish this problem. Y'all go to class. It'll be on the video. I'll upload it as soon as I can. Okay? Point A has an x-coordinate of -3. So evaluate the function to find the point's y-coordinate. I can't just guess at the y-coordinate. Thank you very much. I can't just guess at the y-coordinate. So, point A has an x-coordinate of -3. Evaluate the function to find the point's y-coordinate. Okay? So, I'm just taking this function right here and plugging in a -3 for x and a -3 for x. So I say 4 times -3 plus 1, 2 times -3 minus 3, like that. Or you can go here to your calculator, Control T, and tab to get the equation to come back up, and actually go in here and put in 4x plus 1, and then 2x minus 3, and then go to your, and then enter, and go to your table over here, okay? And then I'm looking for an x value of -3. Now, hopefully you see by now that just evaluating at that value would have been a lot easier because we still have our same table set up as last time, and I have to go all the way back up here to -3 to see that it's -0.5. Oh, except it didn't change my equation. Great. Control T to make that go away. Tab to go up here. So it was mad at me. Great. 4x plus 1 and 2x minus 3. Now it's the new function. Sorry. Now it's the new function. Okay. So when I go to my table, Control T, we are already at, oh no, I'm not, I moved it back. Oh, it did change my values over here, so that's good. So I need the negative, when x is -3. So y is 1.2 repeating. Again, that could have been easily solved by just going ahead and doing the math right here without having to mess with your calculator. Okay. Now, point B has a y coordinate of 5.5. Set up and solve an equation to find its x coordinate. So this is a little different because you know the y coordinate and you have to find the x coordinate. This is 5.5 equals 4x plus 1. This is a lot like what we did Friday. Okay, so where you have to multiply both sides by the denominator. This is our stuff for today. Okay, evaluate over which interval this value is greater than 5.5 and evaluate over which interval this value is less than or equal to 5.5. Okay, so if we're looking here, I'm going to let you do this one by yourself, okay, except I need to know my x-coordinate of my b. So figure this out. X-coordinate of your b is going to tell you a lot about what you need to have here, because you've got your asymptote on your graph, right? We did that for you left. Find your x-coordinate of problem number 3. That will help knowing where this value is, okay? Come and ask me questions in the morning if you need any help.